Hello, this lesson is 3.1, Properties of Linear Functions. Now, this is really more of a review and pooling all our knowledge of linear functions so far and being able to connect some of our new knowledge and some of our previous knowledge, even before this class, and putting them all together. Our EQ today is you actually have to write your own two linear functions that when they're equal to each other, x equals 6. Please remember, neither of them can be horizontal lines. Okay. Now, before we get started on this, I thought we'd do some review problems of these. I taught you a shortcut, and I want to make sure that you remember it so that you don't have to write it out like this, but that you also don't write me the answer of this. Right? That's not the answer. I left a big break because don't forget the middle term. And remember, to find the middle term, you're going to take these two, you're going to multiply, and then multiply them together, and then double it. So 3k times 2 is 6k. You may want to try B on your own if you want to pause and unpause. So you're going to square this, you're going to square that, and then middle term. Multiply and double it. Now remember, this is negative, so it's still going to be negative, because 2 times negative 6 is negative 12. Ooh, that's bad. I forgot my 6. I'm sure one of you yelled at the screen, Miss Mendoza, you forgot, and I appreciate that. All right, try those two. All right, square it, middle term, multiply and double. Yeah, so this last term in the back is always going to be positive because you're going to square it. And even if you're squaring negative, it's going to be positive. So this one, some students just freak out like, I can't do it. Just do what it says. It doesn't matter what you see. You just, whatever's in front, you square it, right? Because that's what it says. And then you square the back. Okay. And then you multiply the numbers. 4 times 5 is 20, times 2 is 40, and then multiply the variables, x, y. That's it. Okay. Let's move on to linear functions. Now, we know about the slope of linear functions. We have positive, negative, and zero slope. But this year, we talked about intervals, increasing, decreasing, and constant intervals. So how does that apply to slope? Well, a linear function, the slope's not going to change all the way through. It's going to stay the same. One of the properties of a linear function. So if we're looking for positive slope, is that going to be increasing, decreasing, or constant? Well, remember how we talked about going up from left to right? It's increasing. So when we're talking about linear functions, they're really the same thing. We're talking about positive slope and increasing interval, which would be, for this, our increasing interval in interval notation. Now our negative slope would be then decreasing along the whole function. And then this, because the slope is 0, it's flat, it is constant. So it's taking an old concept of slope and putting it with a new idea and terminology of increasing, decreasing, and constant intervals. And just connecting the two. All right, so let's pull more things together. Well, do we know how to graph a linear function? Yep, I do. And one of the first things we need to know is slope and y-intercept, okay, which is what they're asking for A. So my slope is right here. It's in front of the x because it is in slope-intercept form. And it's your B. Okay. So we're just going to graph our B first, go down 2 and 3 to the left, down 2 and 3 to the left, and don't forget to connect your points. All right, so we'll determine the average rate of change. Well, what's the average change of the function? Can you figure it out? What's your guess? That's right, I talked about the average rate of change is slope, especially for a linear function. So that's right, it's the same thing. Average rate of change is just negative 2/3. So again, old idea, new name. So determine whether the function is increasing, decreasing, or constant. Well, let's look. From left to right, it is going down. So that is decreasing, which would make sense because our slope is negative, right? And that's it. See, not so bad. Now, another way to analyze functions is in a table. Now, this is not as obvious if it's a linear function because it's not graphed. And we don't want to graph it. We want to be able to determine it in the table. Now, remember that slope is rise over 1 or delta y over delta x. So we have to find the change of these things. This is your x's. Don't forget this is your y. So the change really means the difference, right? Because this is what we're doing. We're subtracting your x's and your y's. Oops. Not bad. I said x's and y's and then literally wrote y. So to find the change, I'm going to take these two numbers and literally find the difference or subtract, and that's 1. From these two, I have 2. And these two have 4, and then 8. Okay. And then over here, it's 1, 1, 1, 1. Okay. So if I put this number over this number, I would get 1 over 1. And then this number over that number, that's 2 over 1, and 4 over 1, and 8 over 1. Now, are they the same? No. So the rate of change is changing through here. Bonus point if you actually know what kind of function that is. Not linear. Okay, so this one's not linear. Not linear. So let's try this next one. Okay, so this one's 1, 1. Does this confuse you, my little c's? Okay, then I won't do it on this side. So if I'm just subtracting, I'm going to get a negative 0.4. Oh, it's not a negative 0.4, it's just 0.4, right? And then the next two numbers, I also have 0.4, and then 0.4, and then 0.4 for these two. Okay, so if I take my delta y's over my delta x, my differences, I have 0.4 over 1, 0.4 over 1. Well, that's pretty obvious, right? You're like, Mr. Josie, you don't have to write down. I understand. So they're the same. So is it linear? Yes. Now, once I'm done, read the directions, determine whether the function is linear or not. Nonlinear, yep. If it is linear, determine the slope. All right, you're going to say, oh, Ms. Mendoza, that's the slope. Yes, but you know how I feel with decimals and fractions. No, you can't leave it like them. So I'm going to get rid of the decimal by multiplying by 10. I will move the decimal over. And then you're going to simplify that. Divide by 2, so I have 2/5. And that would be my slope. Ooh, multiple linear functions. Okay. So what do we see? What are we given and what do we know about that? Well, I have a function, f of x, and it's 3x minus 4, so it's positive. So it's increasing throughout its interval. G of x, negative half x plus 3, that's decreasing through the interval or over the function because there's a negative slope. All right, what's my first problem? It says solve for f of x equals 0. Okay, that's something we've done before. And you do what it literally says. It says f of x. Okay, so what's f of x? 3x minus 4. And what is it? It equals 0. So literally just do what it says. There. And then solve for x. Okay, so x equals 4/3. So, well, what is that? Well, that's an x. When x is 4/3, the y was 0. Oh, that's an x-intercept. It's pretty cool. All right, let's look at this one. So this one says g of x is less than 0. All right, so just do what it says. What's g of x? Well, g of x equals this. Okay, so I'm going to write that down. And it is less than 0. Less than 0. And then you just do it, right? Just write it down. Don't overthink it. And then just do what it says. Okay. And then just solve. All right. Now, many of you want to divide by a half. Don't do it. It's actually a little bit more confusing. -3 divided by -1/2. People get confused. But if you multiply by the reciprocal, which is 2, this will go to 1, and a positive 1 at that. And then, oops, forgot negative. It's +6. Now, when you divide by negative, what happens? That's right. We switch the inequality. So don't forget about that. So it's saying once x, the graph, the function hits at 6, right, wherever, it will go underneath the x-axis. Yes, because when it's, right, yes. Now once it goes, because it's greater than 6, and it goes underneath, because it's decreasing. Okay. And then C, let's see. Well, let's see. It literally says f of x equals g of x. So you literally do what it says. So we're seeing where the two functions, right, equal the same x. So f of x is this, equals, and then what's g of x? That's it. And then you just solve that. Okay. I'm going to add 4 to both sides. 7. Now, we could add a half to the other side, but I know that confuses some people. But remember how I talked about clearing the function, or the clearing the fraction at the very beginning of the year. So you're going to multiply everything by 2. So I have 6x equals negative x plus 14. Going to add the x. So I have 7x equals 14. Ooh, x equals 2. Lovely. Lovely. Okay. All right, D. F of x is greater than or equal to g of x. Well, wait. Isn't that almost identical to the problem before? It does. What's the only thing that's different? Well, does that mean that's what the only thing that's going to change is here? That I don't have to do it? We just write that? Well, let's try and see. So again, f of x, that's what it is greater than or equal to whatever g of x is. Plus 3. Okay. So we're going to add 4. All right. It turns out to be the same thing on the left side. Over here. Okay. Going to multiply everything by 2. Okay. Did that. I'm going to add my x, right? 7x greater than or equal to 14. Divide by 7. Oh, look. It is. The only thing that changed was that, right? Because the f of x didn't change and the g of x didn't change. Excellent. Okay. And moving on. Well, hopefully that helped you understand linear functions and connecting some of the new things that we learned this year. Okay, class, until next time, be well. Bye.